Good morning, everyone. We are now dealing with the April 2020. So this is the April 2020 Maths N5 exam. It was supposed to be written in April 2020, but because of the lockdown, it was written in July. So this is definitely the latest exam paper. And so we're going to deal with, I'm starting with area, volume, because area and volume are very important. You start off in N5, well actually in N4, but it gets much more involved in N5, and then N6 after the exam deals with applications with of integration. This is what we're doing. So if you're watching this video, see, I've checked my analytics there. There are many views, but make sure you subscribe also to the channel. Alright. So once I get 1,000 views, then I'll be able to do a live lesson at any time. So I'm almost there. Sorry, not 1,000 views, 1,000 subscribers. Then I'll be able to teach live. Okay, anybody in the world. Right. So now let's deal with this one here. So we're given y is equal to x plus 1, x is equal to 0, and y is equal to 2x squared. So we're given those three graphs, three equations. Calculate the coordinates of the points of intersection. Okay. Now, what graphs do we have? We have y is equal to x plus 1. So y is equal to x plus 1. We got x is equal to 0 and y is equal to 2x squared. Now, calculate the coordinates of the points of intersection. Okay, so we should have an idea of how these graphs are going to look even before you work out the points of intersection. And you should be familiar with this is a parabola. So this is your parabola and it's in the form y is equal to ax squared. This is your straight line in the form y is equal to mx plus c, and this is also a straight line. And so this is a straight line, this is also a straight line. X is equal to c, x is equal to a number. Okay. Now, basically we are dealing with three graphs. Right. So now, y is equal to 2x squared is a graph that will turn at the origin, and the coefficient of x squared is positive, so therefore it's going to be pointing up and defects. Then x is equal to 0 is a straight line. So there's your x equal to 0. It's a vertical line. So this is y is equal to 2x squared. This is x is equal to 0. You should have an idea before you work out anything. Okay, have an idea of the picture. We are going to sketch it properly here just now. And what is this one? Y is equal to x plus 1. Okay. So y is equal to x. You should know that's a basic straight line. So x plus 1, that means the graph is shifted 1 unit up. So therefore, you're going to have an x-intercept of minus 1 and a y-intercept of 1. So basically this is going to be a minus 1, this will be a 1. So here we have points of intersection. Okay. So how many points of intersection do we see here? Right. So it's actually 3 points of intersection here. There's one at this point where the straight line y is equal to x plus 1 is intersecting the parabola. There's another one here where the same graph is intersecting the parabola, and at this point here where the two straight lines intersect. Okay, so this is also a point of intersection, which we already know the coordinates of. Okay, we know that here x is equal to 0 and y is equal to 1. If we actually find a y-intercept. Alright, so the main points that we need to find by calculation is the intersection points between the straight line y is equal to x plus 1 and the parabola y is equal to 2x. With the other one, just by inspection, you can see what's going on. Alright, so let's write this down. So let's take the main two first. Let's find these two here. So we know that y is equal to x plus 1 and y is equal to 2x squared. Simple. All you do is solve simultaneously. So if I replace, let's call this y1, let's call this y2. If I replace y1 with y2, so therefore 2x squared is equal to x plus 1. Now, this is a quadratic, make it equal to 0. So 2x squared minus x minus 1 equals to 0. Can this be factorized? Right. If it can be factorized, or even if it cannot be, whether it can or cannot be, you don't have to factorize. You can use the formula if you want to. You can use the formula because this is not a test on factorization. This question is based on volume and area. Alright, so you can complete the square or use the quadratic formula, or if you pass to factorize it, then you factorize. So we got 2x and x, and this can only be a 1 and a 1, and it's a 1 and a 1 there. Now the signs. Okay, you need to be careful. You check your signs. Where do you put a positive? Where do you put a negative? So this middle term is a negative. So this will be negative, that will be positive. If you check 2x times minus 1 is minus 2x. 1 times x is 1x, minus 2x plus 1x will give you minus x. Right, that's checking my middle term. So we know that 2x plus 1 is equal to 0, or x minus 1 is equal to 0. So x is equal to minus 1 over 2, or x is equal to 1. Okay, so these are the x coordinates at the point of intersection. Now we need the corresponding y values here. So we will substitute into any one of the original equations to get our corresponding y values. So when x is equal to minus 1 over 2, let me use let's use this one here. Minus 1 over 2 plus 1. So I'm using equation 1 there, x plus 1. So minus 1 over 2 plus 1 is just going to be half. Basically 1 minus half is half. Right. Also double check, substitute into the equation 2, make sure you get the same answer. If you do not get the same answer, then there's a mistake. What else? When x is equal to 1, y is equal to x plus 1, so that's 1 plus 1, which is 2. Okay. Now, those are the points of intersection of these two graphs there, which is, what did we find now? Minus half and half. And then we have 1, 2. Now, what else? There's also points of intersection between the two straight lines there, because clearly you are given 3 graphs, okay, and you are asked to find the points of intersection, so we must find all points of intersection, not just these two. Okay, so now let's deal with y is equal to x plus 1 and x is equal to 0. Well, this is a straightforward one. These two graphs, where do they intersect? There's equation 1, equation 2 if you want to call it. All you do is take x is equal to 0, substitute there. So when x is equal to 0, what is y equal to? Y is equal to 1. Remember, that was our rough sketch. This is not the proper one, that's just a rough sketch. So we have an idea. You must have an idea of what you're working on. So we got 0 and 1. Right, so we got 1, 2, 3 points of intersection, not 2. Okay, because we are given 3 graphs. Now, let's make a larger sketch of what we have here. So that was just 2 marks. So that's 5.2.1, 5.2.2 now. Make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. Right, so sketching y is equal to 2x squared, you can use a table for that. Okay, so if you've never sketched y is equal to 2x squared before, this is how you do it. You go y is equal to, so you got x, and then you have y is equal to 2x squared. And then you just substitute values and then get the corresponding. Substitute values for x, get corresponding y values. You can use the table function on the calculator. So if you press mode number 3 on most of the calculators for number 7, then you get your table and then you type this out and it will give you, you can start, it's up to you where you want to start. Look at these values here. You got minus half, you got 1, 0, so you don't need to go and substitute too many values. Let's start at maybe minus 2. So let's go minus 2, minus 1, 0, 1, 2. It's up to you where you want to start and where you want to stop. Okay, so you know when you press mode on your calculator, then f of x will appear, then you will type out 2x squared. Then you will press equals to, if it asks you for g of x, just press equals to again. Or, yeah, you just press equals to again. Then, the question, you will be asked for the start value. The start value I'm choosing is negative 2. You press equals to. Then the end value is positive 2. Press equals to. Then the step value. Step value, the difference between these coordinates is a constant 1, so the step value is 1. You press 1, press equals to, and in just 1-2 seconds, you get everything. Right. So if you're not familiar with using that function on the calculator, then you do it by normal substitution. What do I mean? When x is equal to minus 2, substitute minus 2 here. Minus 2 squared is 4 times 2 is 8. When x is equal to minus 1 squared is 1 times 2, which is 2. When x is equal to 0, 0 squared is 0 times anything is 0. When x is equal to 1 squared is 1 times 2, which is 2. And when x is equal to 2 squared is 4 times 2, there, which is 6. So you have an idea of the values. Okay. Remember, you don't have to show this in the exam. This is just for your understanding on how to sketch this type of parabola, ax squared. And so you know this is the shape of your parabola. Right, so that is your parabola. Y is equal to 2x squared. If you want to show the values, we will show these values just now. Let me just put this as 0, 0. Then we have the graph y is equal to x plus 1. If I want to work out the y-intercept, I will let x equal to 0. Okay, so let me just do that there. So we got y is equal to x plus 1. If you want to work out these values, when x is equal to 0, what is y? Y is equal to 1. And then when y is equal to 0, when y is equal to 0, x is equal to minus 1. If y is equal to 0, x is equal to minus 1. So those are the x and y intercepts of this straight line. So we got minus 1 and we have 1 there. So this was negative 1 and this is a positive 1. Right. Now, show the points of intersections clearly. Make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. Okay. So this point here that we worked out was minus 1 over 2 and 1 over 2. This point here was 1 and 2. We call, what did we label, how did we label our graphs? We call this straight line here y1, so I said y1 is equal to x plus 1. This parabola here, we call it y2. So y2 is equal to 2x squared and x is equal to 0. This is the straight line, x is equal to 0. So x is equal to 0 is the y-axis. That is the equation of the y-axis. Right, now let's check. Oh, sorry, we forgot to. We need to include the representative elements, the representative rectangle. So it's best in this situation to use a representative angle with a breadth of delta x. Okay, now, right, so calculate make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. So where is the enclosed area? In between all three graphs. Okay, in between all three. So there's basically an area, we count 1, 2, 3. There's this area here, and there's another area here. Can you see that? Okay. So basically it was pointless to go and write down, I mean the question stating, including that value x is equal to 0. Okay, so because there is an area on the left of x is equal to, there is this small area here, and on the right of x is equal to 0. So basically the area that we are looking for is this entire region here. This entire area. Can you see that? So let's draw our representative rectangle. With a breadth of delta x. And check what's touching the top end and what's touching the bottom end of that rectangle. So what's touching the top end here is y1. What's touching the bottom end of your rectangle here is y2. Now, that's basically it. Nothing more to do for this one. We now need to work out the area. Right, so the next question is calculate the magnitude of the area. So that will be 5.2.3, calculate the magnitude of the area. So what do we know is that your area is equal to your length times your breadth. So area of the representative rectangle. So we're going to go delta A, which is area of the representative rectangle, is equal to, what is your length? Your length there is the difference between, let me just redraw this. So there is your representative rectangle. Your breadth is the difference between the x values. So your breadth is delta x, and your length, what did we label this as? y1, y2. So the length is the difference between the y values, y1 minus y2. So your area is going to be length y1 minus y2 times your breadth, which is delta x. So this is a compulsory step. You have to write this down. So now, total area. Once you write down total area, you do not write down your delta sign there. Now you put in your integration sign. You are integrating. And now, delta x, once you put in your integration sign, delta x now becomes dx. You are integrating with respect to x, and you are integrating from a to b. We are only interested in the x values at the beginning and at the end. So, what is your b and a? So you go to those 2 points of intersection. Okay. And we have a minus 1/2 and 1. Those were the intersection points of the straight line and the parabola. We don't have to use the intersection point of the two straight lines. Okay, you don't have to do that unless you are doing delta y, which is a different situation. y1, what is y1? y1 we labeled it as x plus 1 minus y2, which is 2x squared, and this one is an easy one compared to other exam things. Okay, you can see the integration part is simple. So now we integrate. This is going to be x squared over 2 plus integrate 1, that will be x integrate minus 2x squared, that will be minus 2x to the power 3 over 3, and we need to substitute 1 and negative half. Right, so let's see what we get. So when we substitute 1, I will get 5/6. Then substitute negative half. I'm getting minus 7/24. Double check needed. So you get 9/8 as your final answer there, which is 1,125 units squared. Don't forget area is squared. Right, so that was 5.2.3. Now that was also only 2 marks here in this one. The next one is calculate the volume of the solid of revolution formed when the area is rotated about the x-axis. Okay, so this one is 5.2.4. Okay, so the question is, the state area is rotated about the x-axis. Okay, now in order to work out the volume, okay, first of all, there's your representative rectangle. Your representative rectangle with a breadth of delta x is perpendicular to the axis of rotation. Okay, I'm just giving you the reason, because when you come to N6, this is how you need to answer the question. And you need to understand whether your representative rectangle is perpendicular or is it parallel. Now, why are you using this method which I'm going to mention now? It's because our representative rectangle is perpendicular to the x-axis. So there's your x-axis and here's your representative rectangle. So it forms a perpendicular situation. So if delta x is perpendicular to the axis of rotation, then we use the disk method. In N5, you only do the disk method, but you need to know why you're using the disk method. Okay, so what is the disk method? The disk method is volume is equal to area of base times the perpendicular heights. Okay, so this is all the reasoning for why we're going to be using this. Now, there's a compulsory. This is just for your understanding. For those moving on from N5 to N6, this is the reasoning. Now, compulsory step to answer here. You're going to write down delta B x. This means axis. If I write down the small x here, it means that is the axis of rotation. How do I know that? The question stated x-axis. Okay. So now, I told you that there's a simple way to remember this here. It's going to be, okay, let me just do this properly, right? So now, area of base times perpendicular height. In this case, we're going to take the volume of the top graph, just like how we worked out the length is top minus bottom. So with volume, it's going to be the volume of the top graph minus the volume of the bottom graph. Okay, so I'm just going to show you how this equation comes about. Now, what is the top graph? The top graph is, according to how we label the top graph here, is y1. Okay, so it's going to be pi y1 squared times delta x. Okay, because your radius is measured in terms of y. Now you're rotating around the x-axis, your radius is measured in terms of y. So it's pi y1 squared delta x, that's area of base times height, minus pi y2 squared delta x. Volume of the top graph minus volume of the bottom graph. Now you factorize this, take out pi in front, and take out your dx at the end there, and there's your formula. Can you see the formula? Remember, I told you the easy way to remember this here in N5 is, there's your area formula. For volume, all you do is put a pi in front, square that, square that. so there's your pi in front, square there, square. That's just quick method. Okay, but for understanding, you must understand that it's top half minus bottom half. Okay, so now total volume. So that will be Vx, total volume. So you don't write down delta now, so that will be pi. Same, you're integrating from A to B. It's the same A and B, yeah? Y1 squared minus Y2 squared delta x. And now, let's substitute for Y1 and Y2. It's the same Y1 and Y2 that we put here. Same B and A. What's your B and A? Minus half and 1. What is Y1? And what is Y2? So Y1 is x plus 1. And then Y2 is 2x. This is in fact, this is a simple one to compare to other examples that we've done. Right. Let's hope you get a simple one in the November paper. So that's equal to pi. Now here, do I need to square this? This is not in standard form. It's not in standard form, so I'm not going to integrate at the moment. Let me square it. So that is going to be this one. There's no need to square this whole thing. You can if you want to. It's going to be x squared plus 2x plus 1. But I can see this is type A. Type A, exact derivative. This is f of x, f prime x outside. You must be familiar with your type A, B, C, D. Here, minus, when you square this is not in standard form. You have to square this one. So that will be 2 squared, that will be 4x, and then 2 times 2 is 4. Right, so now they are all ready to integrate. So here the exact derivative of x is 1. So I can go straight and use type A. So that's going to be 2 plus 1, which is 3 over 3. This one you're going to integrate 4 plus 1, which is 5 over 5, substituting 1 and negative half. Okay. Let's do the substitution and see what we get. So when I substitute positive 1, I get 28 over 15. And now when I substitute minus half, I get 1 over 15. So that's 27 over 15. So that's pi times 1 comma 8. Which is the same as 9 over 5 pi, which is the same as 5 comma 6 5 5 units to the power 3. That is the volume. Look, this was a simple example compared to other examples in the N5 paper. But if you have any questions, you can always, while watching this video, there's a comment section. Upload your question there if you have any problems. Now, let's continue with this paper. Let's go to the integration parts. Okay, let's continue with, we're going back to question 4. Integration 4.1.1. We need to integrate that, so let's write it down. Now, a common mistake is when you transfer information now to your answer booklets. So this question has y is equal to 4 over sec times e to the power sine x. But the question says determine the integral. That means you need to put in your integration sign there. Many of you, when I'm marking your papers, you're just writing down the y. Okay, so be careful. It is determine the integral of y dx. So 4.1.1, when you're answering the question, you straight go and put in your integration sign and then replace y with what you see here as it is. So that will be 4 divided by sec x times e to the power sine x, and there's your dx. And this is how the question must be. Right, now let's see what we're going to deal with here. So clearly, there's no formula. There's no standard form where you have sec as a denominator and e as a denominator. That means we need to simplify, you need to rearrange the sec. So, well, you know, any constant that you have, multiply it by the number in front and leave it there. That's your form. Okay, now you need to know your trigonometry here, otherwise you're going to have a problem. This is 1 over sec. So this is your identities, reciprocal identities. 1 over sec is the same as cos. Now, you must not leave e in the denominator. You need to take the base to the top, and when you take the base to the top, what happens to the sign of the exponent? It changes. So if it was a positive, it will change to negative. That's all. Now, be careful. This looks like integration by parts because it's multiplication. It looks like integration by parts, but it's not. Okay, so be careful. This is type C. So let me just show you what I'm talking about. Type C deals with e to the power f of x multiplied by f prime x. This is type C. Okay. So in a situation like this here, we let u equal to f of x. So du over dx is going to equal to f prime x. So dx is going to equal to du divided by f prime x. I'm just showing you the standard form here quickly. So what happens in a situation like this? You have e to the power u, because f of x is now u, times f prime x. There's my f prime x times dx, and dx is du divided by f prime x. So type C deals with exact derivatives. F prime, the exact derivative must cancel. If it does not cancel, then that means it was never type C in the first place. So that's e to the power u du. And when you integrate e to the power u, it's just going to be e to the power u plus c. What was u? U was f of x. Right, so that's for your understanding. To deal with any type C example, you must understand derivatives. See, you must know the derivatives because you must be able to recognize that this is f of x, this is f prime x. So you can do it in one step by inspection, or you work it out by u substitution. So I want to use the u substitution here for the benefit of everyone. See, not everyone knows how to do inspection. So let's follow this u substitution technique. So what do we know? F of x must be let equal to u. So you let u equal to minus sine x. The exponent is u. Now all you do is differentiate du over dx. The derivative of negative sine is going to be negative cos. And now you make dx the subject of the formula, which is du divided by minus cos. You can see that? And now, just substitute. So this is equal to 4. You've got cos x there. You've got e minus sine x is no more minus sine x. Minus sine x has been replaced with the letter u. And dx is replaced with du divided by minus cos. And now, where are we? We are at this stage here. Can you see f prime x, f prime x? F prime x, f prime x, they must cancel. That is type C. So therefore, don't forget that there's a negative here. You can see that? So 4 divided by minus 1 is minus 4. Cos and cos cancel. You end up with just e to the power u du. Where am I? I'm at exactly at this point here. Can you see that? K, which is minus 4, e to the power u du. So when you integrate e to the power u, it's just e to the power u plus c. Substitute back for u. What was u? U was minus sine x plus c. So this is done by the method of u substitution. If you know inspection, you can do it. Up to you. Right, so I'm going to deal with the next example now, which is this one. I'm not going to erase the body, it's still up and down. Right, 4.1.2. What are we dealing with here? Now, I always encourage you to know your differentiation. So when I look at the example, I'm always checking for exact derivative. Just like with the previous example, I knew that the derivative of the exponent minus sine x is going to be cos. Right, not exactly cos, but the fact is you're going to get cos, which is going to cancel. So I know now that this is an inverse trig function. Okay, so this is your inverse trig function. Here we are dealing with y is equal to k times inverse cos f of x. Looking at that inverse cos thing. So the derivative of inverse cos f of x is going to be minus f prime x all over the square root of 1 minus f of x all squared. That is the derivative for inverse cos. So in a situation like this, I can see that if we differentiate this, I'm going to get an exact derivative. Okay. So this is in the form of type A now. Watch what I'm saying. Type A. So how does type A work? Type A, remember that if you have f of x all raised to the power n, just like what we have the power 4 there. Can you see that? Multiplied by the exact derivative, which is f prime x. Then, in this situation, we will always let u equal to f of x. So du over dx is going to be f prime x. So then dx is going to equal to du divided by f prime x. This is u substitution. So what happens now? If I go here, this will be k, and then f of x will be u to the power n. Then I'll have f prime x there, and then dx is going to be du divided by f prime x. So what happens? Whether it's type A, B, C, D, the derivative will always cancel it, just like the previous one. So what will happen now? You end up with k, and then you have u to the power n du. Okay. And now all I will do is integrate with respect to u. So that's going to be u to the power n plus 1 all over n plus 1 plus c. Now this only works when n must not equal to negative 1. Okay, that means your exponent must not be minus 1. If it's not minus 1, then it's fine, you can do it. If it is minus 1, then it moves to type B, it won't be type A anymore. Right, so substitute back at the end. What was u? U was f of x, so that is f of x to the power n plus 1 over n plus 1 plus c. Let's do it here. So now you might think, now where is the multiplication? You must know how to manipulate a question like this here. Right, from division to multiplication. You must understand that, let's say, let's say 2 over 3. That's a fraction, 2 over 3. Is the same as 2 multiplied by 1 over 3. Okay with that? So that's exactly the logic we need to use here. This is the same as inverse cos 2x to the power 4 times 1 over the square root of 1 minus 4x squared dx. It's the same thing. Division, multiplication. You can see from division to multiplication. Now, what do? We know that this now is your f of x. There's your f of x. You can see that. There's your power n, and there's the exact derivative f prime x. It can be done in one step by inspection, but I'm not doing inspection at the moment. I'm doing u substitution. So always let u equal to f of x. So what's inside here? So you're going to let u equal to inverse cos 2x. Now I need to go to my formula sheets. Okay. And then identify my f of x here is 2x. Forget this, we're not talking about this f of x. We're talking about the f of x for the specific function, inverse cos. So then du over dx. How does this work? F of x is 2x. The formula is minus f prime x. So it's minus the derivative of 2x, which is 2. Can you see that? All divided by the square root of 1 minus 2x f of x, which is 2x, all squared. Right. Which is the same as minus 2 all over the square root of 1 minus 2x all squared is 4x squared. Now, make dx the subject of the formula. So, I've got a fraction on the left, fraction on the right, cross multiply. Okay. So if I cross multiply there, I'm going to have the square root of 1 minus 4x squared times du is equal to minus 2 times dx. Can you see what's happening there? That is cross multiplying. I may need to make dx the subject of the formula. So the square root of 1 minus 4x squared du divided by minus 2 is equal to dx. As you can see, differentiation is, that's the foundation integration. If you don't know differentiation, you won't be able to do anything. You must know the differentiation properly. Let's do the substitution. And obviously your standard forms. Now, this is equal to the integral cos 2x, I mean inverse cos, there's no more inverse cos. What is inverse cos 2x called now? We replaced it with the letter u. Dx is no more dx. There's dx here. Can you all see that? So dx is the square root of 1 minus 4x squared divided by minus 2 du. And now it works out nicely. You can see that. Exact derivative cancels it. There's a check. This is where I am at the moment. Exact derivative will cancel. So now, what happens now is you end up with, don't forget there's a -2 in the denominator. That means there has to be a 1 in the numerator. So it's -1 over 2u to the power 4 du type A. You always come to something like this. There's a gem. This is where we are now. You can see that. Compare. Now integrate, substitute. So this is going to be -1 over 2 u to the power 4 plus 1 will be 5 over 5 plus c. And now you're done. Now all you have to do is substitute back for u. So this becomes -1 over 10 u to the power 5 plus c. What was u? U was arc cos or inverse cos 2x. Let's move on to the next one. Right, the next one. This one is 5 marks. Why is it 5 marks? So clearly you have a fraction. The numerator is of a higher degree than the denominator. We normally use long division to work these types of examples out. Right, but x plus 4 is in the denominator. I'm not sure if x plus 4 is a factor. Let's check it out quickly. Right, let me have calculated it. Let's check if x plus 4 is a factor. Why am I doing that? Because if x plus 4, if x plus 4 is a factor, then it will cancel if we can factorize it. So before we start off anything, let's check if I substitute -4. Let's see, will it work? So I want to substitute -4, and if I get 0, then I know that x plus 4 is a factor. So let me just try it out first. So let's try the -4. No, it's not a factor. So we're using long division straight. Okay. So now that's why that's 5 marks, because of the long division. Yeah. So long division, we've done long division before. You can always check the N6 work. Partial fractions, remember that one? We're dealing with long division. But here, let's see, we got x plus 4. And then we have x cubed plus 2x squared plus 9x minus 17. Now, long division, 4 steps. We've done it before many times. So it's divide, multiply, subtract, bring down. It's a 4-step algorithm. You go back. After you're done with step number 4, you go back and you carry on doing it until you cannot divide, until you have a proper fraction. So what is this called? This is called an improper fraction, because the top is bigger than the bottom. Okay, so now let's go for step number 1, which is divide. So term 1 divided by term 1, x cubed divided by x will be x squared. Multiply, x squared times x is x cubed. X squared times 4 is 4x squared. So that is multiply. And now the next step is subtract. Top minus bottom. Okay, by now you should know it. Okay, top minus bottom, just a subtraction. 2 minus 4 will be minus 2x squared. X cubed minus x cubed. You must always get a 0. Here's your first one. Okay, if you don't, you made a mistake somewhere. Next step is bring down all remaining terms. Don't bring down only this one, bring down everything. So you're bringing it down, so it becomes plus 9x minus 17. So we're done. 1, 2, 3, 4. Check now. Okay. This is still larger than that. So that means we must continue dividing. This is x squared. This is x to the power 1. So we continue. So 2x squared divided, minus 2x squared divided by x is going to be minus 2x. Multiply the answer that you just worked out by everything here. Minus 2x times x is minus 2x squared. Minus 2x times 4 is minus 8x. There is no constant here. Can you see that? So write down plus 0. There is nothing. Nothing means 0. Subtract. Okay. Top minus bottom, minus 17. Top minus bottom, plus 17x. Top minus bottom, 0 straight. Okay. So now, bring down, there's nothing to bring down here. So go back, check. We got an x and x, they are equal. That means you still can divide it. Can you say that? So you go back. That's why it's 5 marks, because you're using the process 3 times. You can see that. 17x divided by x will be plus 17. 17 times x is 17x. 17 times 4, that will be 68, correct? Plus 68. Right, so now top minus bottom, so that will be minus 70 minus 85, correct? The minus 85. Top minus bottom, 0. You got that? Right, so now this is your remainder here. You cannot go and divide anymore. So how do you set up the next part? You did this. Now you need to write down. You need to take the correct information and put it in the correct place. So let's write this down now. So what did we have? We had the integral of x cubed plus 2x squared plus 9x minus 17, all divided by x plus 4. And now it is equal to what we worked out here. This is the quotient. Okay. So therefore it's going to be x squared minus 2x plus 17 plus, you always add the remainder over the denominator. Always. Okay, so it's a quotient plus the remainder, which is minus 85, all over the denominator there, x plus 4. Right. This is not difficult, okay, compared to other things. This is easy. It's just a 4-step process, which you need to make sure. 5 marks there. Now, the last part, easy. Okay, so we integrate here. Integrate x squared. So that will be x to the power 3 over 3. Integrate minus 2x, so that's minus 2x squared over 2. Integrate 17, that will be 17x. Integrate this. Now, this is type B. So what do? Put your minus 85 here and write this as 1 over x plus 4. You see that? So this one here is your type B, where the numerator is f prime x, the denominator is f of x. Numerator is 1, denominator is x plus 4. The derivative of x is 1. So that's why f prime x over f of x. And the answer will always be ln absolute value of the denominator plus c. And that was 5 marks. Do we have time for another one?